Okay, this is the online lab that's going to take the place of the Atwoods machine Revenge lab that we would be doing. Still, both of those labs did use energy, and what we're going to do is we're going to more or less set up a virtual pulley. We're going to go ahead and hang a mass off the side, and we're going to say that energy is conserved. So what you're going to do is you're going to click on this link right here, and you're going to leave these guys to be what seems to be the default settings, and we're going to change the inner radius of the pulley to 0, and now we're essentially going to have a solid disk. So let me show you what these guys look like. This is what it should look like when you first started it up. Leave that guy as 100 grams, 500 grams, 100 millimeters. Leave this as earth, and you're just going to decrease this such that we have a solid disk. Now what we can kind of do is we can kind of go back to our document, and we can calculate what the theoretical moment of inertia or rotational mass for a disk ought to be. I don't know about you, but when I look it up in the textbook, it says if I have a solid disk or pulley, it's going to be 1/2 the mass, the radius squared. When you go ahead and you calculate these guys, please make sure that you convert these guys to kilograms, and make sure you convert these guys to meters. That's going to give you a rotational mass in kilograms meters squared. Don't forget the units. For some reason, people always seem to do that. We're going to go ahead and click the start button and allow that thing to fall. And then more or less, we're going to record the height and the velocity at impact. So let's go ahead and take a look at how we're going to do that. You're going to hit the start button. Obviously, it goes down, and you can kind of see the position versus time graph right here filling out. This position right here is going to be the initial height of this mass. What it kind of did is the motion detector called its initial position 0, and it called down to be positive. We can then go ahead and just read the velocity versus time at impact off right here, and we're just going to go ahead and we're going to record those guys into the Word document. Then we're going to go ahead and use the radius of the pulley to calculate the angular velocity of this thing. So what you're going to do is you're going to say, I know that the angular velocity is related to the linear velocity, and in this case, the outer radius of the pulley. This guy right here should be in radians per second at that point. Then we're going to go ahead and identify the flavors of energy that we had. I don't know about you, but it seemed to start off with just gravitational potential. And we had 2 flavors of energy when the masses struck. We had the mass moving, and we had the pulley rotating. Then what you're going to do is you're going to say energy was conserved, so the energy before is equal to the energy afterwards, and you're going to solve for the rotational mass of the pulley in terms of the hanging mass, gravity, the height, the velocity, and the angular velocity of the pulley. So don't put numbers in yet. I want to see m's, g's, h's, and all that good stuff just right here. Then you're going to go ahead and you're going to plug in the numbers and calculate what the rotational mass of this thing ought to be. And then we can compare that with the theoretical that we calculated up in the procedure. I don't know about you, but because this is a simulation, I expect this to be roughly 0% within rounding. Mine was slightly off due to rounding. Probably if I would have used 9.81 for gravity rather than 9.8, I would have done a little bit better. Then what we're going to do is we're going to go back to the simulation. We're going to hit the reset button, and we're going to just goose up the inner radius to 95 millimeters, and we're going to have ourselves a hollow cylinder. So let's go ahead and take a look at what that guy looks like. We're going to go back, we're going to hit the reset button, and we're just going to increase this guy to 95 millimeters, and we're more or less going to repeat the procedure. We're going to hit start. What we can then do is we can first calculate the theoretical moment of inertia or rotational mass for a hollow cylinder, and you're going to go ahead and you're going to look this thing up in the book, and it's going to be 1/2 the mass, and now we're going to have the first radius squared plus the second radius squared. Note that this is just something that we would do in a lab. I don't expect you to know a hollow cylinder for the test. You're more or less going to repeat this procedure and see how close you actually got.